7 is transformations of polynomial functions. Not as tedious. I think you'll like this lesson a little bit better than 3.6. Okay. Some of this stuff is going to seem familiar when we talk about what are our transformations. This goes back to Unit 1 or Topic 1 where we had that green paper and how we know all the different transformations. But we do have one new piece, and this is being able to decide if a function is even, odd, or neither. Okay. Now I'm not talking even and odd versus on, even numbers or odd numbers in the problem. Okay. This is a different definition of even and odd. And with this, in math, various associations come with even and odd. So right now our goal is to just learn what does it mean to be an even function? What does it mean to be an odd function? Okay, so even function, okay, by definition, for all x in the domain, it gives us two options, okay? It gives us the idea that f of x equals f of negative x. So that is if you only have an equation and you want to try and figure it out algebraically. Does f of x equal f of negative x? And I'll demonstrate that. Or is it symmetric about the y-axis? Symmetric about the y-axis is going to mean what? You can take your graph and fold it in half on the y-axis, right? Okay, so those are the two pieces that if something is an even function, it's going to meet those criteria. If you're given a graph, I'm going to look and see if it's symmetric about the y-axis. If I'm just given an equation, I'm going to look and see does f of x equal f of negative x. So when I put in negative x, is it the same? Okay, and you can obviously see this parabola is an example of an even function because it's symmetric about the y-axis. Okay, the other alternative is an odd function. And an odd function, again, we have two options. We have the algebra option. The algebra option says that f of negative x will equal negative f of x. And again, when we get down there, I'll demonstrate how to find those. Or, read this one carefully, symmetric about the origin. Last one was y-axis. This one is symmetric about the origin. Symmetric about the origin. So realize the origin is that center point, yes? The origin is this center point here. And there's two different ways I could explain this, okay? One, it usually kind of sinks in with a rotation of 180 degrees, I believe. Okay, so like if we take this looks like a cubic to me, but if we take this and we rotate it 180 degrees, it's going to be the same. The other option that I always say is if you reflect it twice. So if I take this graph, and I tend to just look at it one quadrant at a time, if I take this graph and I reflect it across both axes. So like if I take this piece right here, after I reflect it across the y, it's going to be over there. But then, if I reflect it down across the x, what ends up happening? It ends up on top of that piece, right? And so, if it can reflect over both axes and land on itself, that's another way to look at it. Okay? So, rotation of 180 or reflection across both axes. And then, the final option is neither. Well, when's neither apply? When it's not even and it's not odd, right? When even fails and odd fails, it's going to fall into the neither category. And that's just here, I can't reflect this across the y-axis. It doesn't land on top of itself. And I can't spin it 180 degrees, okay? It doesn't land on top of itself, okay? Not about the origin, that is. It might if you spin it right here, but we're looking at spinning it around the origin. Okay? So, another way I kind of look at that odd is my diagonal quadrants are similar. Okay, so those are your definitions that you need to know. I believe, what is our formula sheet this chapter? Pink? one of the things down at the bottom of the pink paper that I said at quiz time you don't need to know yet is information about even and odd functions to help you know which is which. So you will have that information. Now, we're going to start with the easier route. We're going to look at the graphs. Okay? Classify the polynomial functions as even or odd based on their graphs. And I guess that technically should say even, odd, or neither. Okay? So, as you look at A, even, symmetric across the y-axis, odd, symmetric about the origin, or neither of those. What are your thoughts on A? Huh?
No.
What are we saying? Odd, maybe?
So even if it's not like grabbed to the point, like it's touching the origin.
Right. And it wouldn't even necessarily have to go through the origin, to be honest. We may have, I don't know if we'll have an example like that or not, but here's the idea. I mean, what can we rule out automatically? Is this even? No, it is not symmetric across the y-axis. Block that option out. So, next plan, and this is where what I would do is I would take, well, A, could I rotate it 180 degrees? So rotate 180 degrees is going to be rotating it upside down. Is it going to look the same upside down? If you take your paper and you rotate it upside down, does it look the same? Yeah. Okay. I can also take, if I just take one of these, like if I take this piece right here, if I reflect it twice, so if I reflect it down across the x-axis, and then if I reflect it over across the y-axis, does it land on top of itself? It does. Okay, so either way we'll work on telling you. So this is indeed odd. I think I did put kind of explanations. I'm not sure if it said you had to, but I'm going to say symmetric to the origin, or about the origin. Okay? So it's just kind of an explanation for you to remember why later. Okay? Look at B when you're ready. What are your thoughts about B? What? It's an ugly graph. Well, we're not judging based on the pretty factor, so.
Even.
If it's even, what does that mean?
The y-axis.
Okay, it's symmetric about the y-axis. Does it fold across the y-axis here? Yeah. Okay, I'm going to be able to fold that across the y-axis. You guys could take, I can't fold the bin Q, but you could take your papers and fold it on that center line. And it's going to line up, isn't it? So B is an example of even. My reasoning is it's symmetric to the y-axis. Okay. What about C? It's the same shape as graph A, yes? I agree, it is the same shape as graph A.
Neither.
Is it still odd or is it neither? What's different about this graph?
It's touching the origin.
Yeah, and again, I'm not going to say, and I wish I had an example. I don't think I have an example. It's not that it has to go through the origin, although ours are tending to today, aren't they? Okay, but here's the deal. If I try, it has to spin around that origin. If I try and spin this around this origin, the center point of that graph is up here, isn't it? I kind of need that center point where everything is kind of symmetric about it to be at 0, 0. That graph's going to be kind of lopsided. Okay? If I take, say, this piece and I reflect it upside down, well, now it's like that. And then when I reflect it over here to this axis, it's over there. Does that match up? It doesn't land on top of itself, does it? Okay, so this does fall into the category of neither. Okay, I can't fold my paper in half vertically, so it's not symmetric about the y-axis. I also can't spin it around the origin. Okay, now the key is not that it has to go through the origin, but that origin kind of has to be a centering point. Okay, and that's what's not happening there.
0, 0.
Right. Yeah, when I say origin, I mean 0, 0.
Okay.
Okay. What about D? What would you guys say about D? Odd? If I spin that 180 degrees, is it going to look the same? Yeah. Take your paper and rotate it upside down. Does it look the same? It does. Okay. And you can tell that it's symmetric about the origin there and that's kind of a centering point. So this is another example of odd. My reasoning is symmetric about the origin. Okay. What about E? Even? Why? If it's even, it means it's symmetric about the y-axis. Y-axis is the vertical axis. Can I fold that mountain in half?
Yeah.
Yeah, it looks like an upside down parabola, doesn't it? And here's the deal. I can take it and vertically fold it in half here, can't I? So this is, I agree, even. Symmetric about the y-axis. Okay. The graphs are the easy part, right? It's kind of easy to see. You have that physical look. I like it when I see graphs. Now, will we always have graphs, though? No, of course not. So, on the bottom part, you'll notice the same question. Okay? It says, is the function even, odd, or neither? Same question we just did. Except, do we have a graph to look at? No. We don't have a graph to look at, which means we're going to be looking, if I back up for a moment, we're going to be looking at these statements now. Does f of x equal f of negative x? Or does f of negative x equal negative f of x? I know that just seems confusing right now, but I'm going to demonstrate to explain it, okay? If I try and explain it, I'll confuse you more. It'll be better if we just try it. So, is the function even, odd, or neither? First thing I'm always going to start off with is they give me f of x, right? And if you look at even, it asks, does f of x equal f of negative x? So I'm always going to start off with finding f of negative x. Now, f of negative x says every place you see an x, what am I going to replace with? A negative x. So every place I see an x, we're going to replace with negative x. So right here, it's 4 x to the 4th. What are we putting in place of x? Negative x raised to the 4th plus 5. Okay, so all I did is I took the x and I replaced it with negative x. Now, clean this up. 4 is 4. What do you get when you raise a negative x to the 4th power? Or a key thing, what do you get when you take a negative and raise it to the 4th power? Negative times negative times negative times negative. What do we know about 4 negatives? They multiply to be a positive, yes? So negative x to the fourth, when I multiply four negatives, I'm going to get positive x to the fourth plus 5. What just happened? What? We went back. Is 4x to the fourth plus 5 the same as 4x to the fourth plus 5?
Yeah.
We did. So we can make the statement that f of x is equal to f of negative x. What does it say up top when f of x equals f of negative x is true? Does it say even or odd? F of x equals f of negative x says that falls under that first graph, and that means it is even. Okay? So I know in this case it is even. Okay, so there's an example of seeing how do I know? There's an example of even. Got it? Okay, let's look at the next one. G of x equals 2x cubed plus 3x. First thing I'm going to start with is g of negative x. Okay, g of negative x. Every place I see n, x, replace it with negative x. So 2, instead of x to the third, I'm going to say negative x to the third plus 3 times negative x. Okay, see what we get here. Clean it up. What is a negative x raised to the third? So what is a negative when you have 3 of them? Still negative, right? An odd number of negatives is negative. So negative x to the third, you multiply that by 2, I'm now going to say negative 2x to the third. What's 3 times negative x? Minus 3x. Okay. Right now, what do we know? Does g of x equal g of negative x?
No.
No, they're not the same, are they? So at this exact moment, I can say, and I guess I'll go ahead and make the statement just so that g of x did not equal g of negative x. So far, at this point, I know that it is not even. Could be odd, but don't forget there's also that neither option, isn't there?
Not applicable.
Okay, so right now, it's not even. Now, if you go back and look at odd, if it's odd, f of negative x or g of negative x, which we already have g of negative x here, don't we? G of negative x needs to equal negative g of x.
So then,
So we have to find one more now. In other words, we have to find negative g of x. Now, what does negative g of x mean? That means we're going to take g of x and multiply it by a negative. Okay? So I'm going to take a negative, and I'll show you as a step here. What was g of x? Negative 2x cubed plus 3x if I go back to the original, yes? We're going to multiply that whole equation by a negative. What happens when you multiply something like that by a negative? Each sign will change, yes? So when you multiply each of those terms by a negative, positive 2x cubed becomes negative 2x cubed, plus 3x becomes negative 3x. So now what? Now I'm looking at negative g of x and g of negative x, according to what it says up top. f of negative x, negative f of x. Are they the same? They ended up being the same this time, didn't they? So, if g of negative x is equal to negative g of x, what am I going to say? I'm going to say that this is odd. Okay? So, easiest thing to do, you first start off by checking even. Check what you get when you put in negative x. So, f of negative x or g of negative x. Then, if that doesn't work, then try multiplying the whole thing by negative. See if that works. If we had gotten to this point and we still didn't have an answer, now we would say neither. Okay? Okay. Ready to try C? No? Yes? F of x is given as 7x to the fifth minus 2x squared plus 4. First thing we need to find is f of negative x. Every place you see n x, put in a negative x, yes? So 7 times negative x to the fifth minus 2 times negative x to the second plus 4.
They just get longer as we go.
Is that what you're thinking is happening? Okay. Let's see. Negative x to the fifth is going to be a what? A negative. Because 5 negatives is going to be a negative. Times this 7 means I'm going to write this as negative 7x to the fifth. Negative x to the second, what do you know about negative x to the second? It's going to be positive. So then this is just going to stay as negative 2x squared. And plus 4 just stays as plus 4. Is this even? Does f of x equal f of negative x? And no, because there's a difference of a negative sign. So I know that f of x is not equaling to f of negative x. So I know it is not even. Okay? If it's not even, now we're going to check. Is it odd? What do we check for odd? Here we checked f of negative x. Now we need to check negative f of x. Go through and multiply everything by a negative. So it's going to be the negative, and we're going to multiply it by 7x to the fifth minus 2x squared and plus 4. Notice I'm using the original function. When I multiply everything by a negative, that changes all the signs, right? This becomes negative 7x to the fifth. Negative times negative becomes positive 2x squared. Negative times 4 becomes minus 4. Now what? Does negative f of x equal f of negative x? Negatives, negative versus positive, positive versus negative. That doesn't work, does it? So right now I know f of negative x does not equal negative f of x. So that tells me it is not odd.
It's neither.
It's not even, it's not odd. It's neither.
So how do you write that, like within the fx, whatever, you just write neither?
You just write neither. My proof or explanation for neither is that it failed the even test and it failed the odd test. Does that make sense? If it fails even, it fails odd, it's neither. Okay. You've seen an example of each. I throw in one more example just because. I wanted to change things up, you know? Now you don't know what D is. Right? By the time we got to C, you guys knew. She showed us an even, she showed us an odd. This one's probably a neither. Well, now, we don't know. I'm going to make you think. Okay, so what if I start off doing every single time?
F negative X.
Every single time, I start f of negative x. That's going to be my first test. So, it's going to become negative x, raise it to the 6, minus 2. Well, what happens? A negative x raised to the 6 is going to be a positive x to the 6. Minus 2 stays minus 2. Okay, what observation can you make right now?
It's the same.
F of x is x to the 6 minus 2. F of negative x, x to the 6 minus 2. F of x equals f of negative x, and so this is even. We don't need to check for odd because it was even. Okay? So keep going till it fits one of the categories is what you're looking at there. Questions there? Okay. Are you drying the ink pen? Okay, let's look at the back side. Back side here. This top section has to do with a lot of what we've already done this year. Okay? It's asking how does the given graph differ from the graph of its parent function. Okay? When we talk about the graph of its parent function, we're talking about whatever that basic graph is, x squared normally. You'll notice in this lesson, we're not seeing as many x squareds. We're not seeing as many parabolas as we are x to the thirds and x to the fourths. So, just kind of for reference here, we're going to talk a lot about the parent functions of the cubic function, which is x to the third, and the quartic function, which is x to the fourth. Okay, so this kind of works for both sections. So how does it differ from the graph of its parent function? So I'm basically looking in A. What's the 3 tell me? What's the minus 18 tell me? Those are the types of things I'm looking for. Okay? And we're going to put it in words. So, I don't know, maybe you need to dig out your half green sheet from topic 1. Or it was also on the blue sheet in topic 2. I don't think I have it on the pink sheet in topic 3. But what do you guys know? What's the 3 say? What's the minus 18 say? Are we going up, down, left, right, stretching, shrinking, reflecting?
Well, that's a long time ago.
And they keep coming back in Algebra 2 is what I will tell you. Yeah, you're going to have to refer back to, if you're not remembering these, either the half sheet, green sheet from topic 1, or your blue sheet from topic 2. Surely you have one of those still, right?
Yeah.
Okay, those are where you're going to have to refer back to. And if you haven't noticed, I'm digging into a pile of both right up here, aren't I? So if you need to grab one. Any thoughts? What do you know, Danielle? Oh, nope. You just have to give me one.
Is it going up, sorry?
No. Brayden?
It's going down. Wait, which one? A?
Example A.
Oh, it's going down 18.
Okay. Do we agree with the down 18? Has it been too long since we've taken a break from these?
I don't even know what hippers are. I had them.
Okay. So if you look at your paper, f of x minus c. When there's a minus c at the end, it's that same chart on that blue paper. Okay. That minus c on the end, notice it says that is our down c. So this minus 18 represents down 18. What about the 3? What about the 3? What do you remember, Brayden?
Hold on, I gotta find it. It's reflected across the y-axis.
No.
Or the x-axis.
Now reflections, what are reflections on there? Reflections relate to negatives. Okay, guys, here's the green paper up on the TV.
Oh,
If there's a negative,
being stretched.
that's going to be a reflection. Okay, that minus c represents the down c, which was the minus 18. Where is that 3? That 3 is where? Right out front, yes? That's a vertical which?
Stretch.
Stretch. A vertical stretch because that value is what?
Greater than 1.
Greater than 1. Okay. I don't know if it's good news or bad news, folks, but it sounds like bad news. We're not done with those.
No, what? We're not.
Okay? We're not done with those. Those are still with us. Those are something, like as topics in Algebra 2 build, that is the one topic that keeps coming back. Okay? We're in our 3rd chapter, and guess what? It's back for the 3rd time. Okay? It keeps coming back. Okay? So, we're going to put this in words. Now, tell me, what's the parent function here?
Y equals x to the 3rd.
Not
X to the 4th.
X to the 4th, yes? So I'm going to put this in relation to my parent function, that it's the graph of y equals x to the 4th, and what's done to it. It has a vertical stretch by a factor of
2,
3, and it is vertically what? Vertically translated down 18, or I guess we usually just said translated down 18. So the function y equals x to the 4th has a vertical stretch by a factor of 3 and translated down 18. That's what I'm going to be looking for. So the function y equals x to the 4th has a vertical stretch by a factor of 3, and I'm going to use that word translated down 18 units. Okay, so to me, I see 3 key things there. 1, I mentioned that it was x to the 4th. 2, I mentioned it was a vertical stretch by a factor of 3. And 3, we mentioned that it was translated down 18 units. 3 key things that I'm looking for there. Okay, that was rough. Is it coming back to us at all? Let's look at B. See what we can do with B here. H of x equals 5 times x minus 2 cubed plus 4. Any of the pieces, can you name what's going on?
The function's being translated right. 2 units.
You guys remember that one? A number added, subtracted inside the parentheses with the x is opposite the left or right, opposite the sign. So that minus 2 is going to be a right 2. Good. What else? What about that number at the end? Yeah, the number added or subtracted at the end is up or down, the direction of the sign. So that's going to be up 4. What about the 5 out front?
Vertical stretch.
Yeah, like the last one, when it's multiplied out front, it's a vertical stretch or shrink. Or did we use compression? Vertical stretch or compression. In this case, it's bigger than 1, so it's a stretch. And what function is this being done on? X to the what? Third, yes? So your parent function is x to the third. So I'm going to say the function y equals x to the third is vertically stretched by a factor of 5 and translated right 2 and up 4 units. So the function y equals x cubed has a vertical stretch by a factor of 5 and translated, what do we translated? Right 2 and up 4 units. Okay. What about C? C should be easy at this point once we've reviewed A and B. What's the 2 doing and what's the minus 5 doing?
Down 5.
Okay. Minus 5 at the end is down 5. It's not in the parentheses or anything. What's the 2?
Stretch.
Another vertical stretch. What is this being done on?
The air factor of 3.
Yeah, x to the third. So, the function,
What's the factor?
you said factor. The function, the graph y equals x to the third, has a vertical stretch by a factor of 2 and is, I used translated, maybe you said moved, shifted, down 5 units. Okay, we'll finish the notes tomorrow. You should have some work time tomorrow for 3.7.